So good evening everyone. Up to now we have completed up to 10 days, 10 classes. So this week we are going to complete the remaining topics. That is, we are going to discuss about arrays, functions and strings. These all topics are very important to us. Today let us start off with arrays, and tomorrow also we are going to discuss arrays. Today's we are going to use for arrays. What is the need of going with arrays? Let us understand. If you declare a variable like int n, how many values we can store in this n variable? Only one value. If our requirement is to store 10 values, then I can declare 10 variables. But if our requirement is to go with 1000 values, can we declare 1000 variables? Very difficult. Our time goes only for typing the variables, and managing 1000 variables is very complex to us. That is a place where we go for arrays. You can define an array like an array is a collection of elements of similar data type. Means what are the elements we are collecting? They should be of same type. Meaning if you want to collect integer, should be integer type. Float means float type only. Should be of similar type and stored in continuous memory locations. So what is this continuous memory location? I'll elaborate in the diagram. Then here we are having two types of arrays. They are one-dimensional arrays and multi-dimensional arrays. So in our case, we are going to discuss two-dimensional arrays. So today we are going to discuss one-dimensional array. In tomorrow's session, we'll go with two-dimensional arrays. Coming to this one-dimensional array, how to declare is, the declaration is, the syntax of declaring one-dimensional array is, we have to go with the data type, then array name, then in square brackets we have to mention the size. That's it. Like example, you can say int n of 5, float salaries of 10, like this. Right? So we have to mention the size, how many elements you want to collect. Like example, when you say n of 5, if you are declaring like this, int n of 5, what is going to happen over here is, since we have given size as 5, it's going to allocate memory where we can store maximum 5 values. It's going to allocate memory where we can store maximum 5 values. All these elements are connected to array n here. N is our array name. Now let us assume the address of first element is 100. I'm assuming address of first element is 100, and let us assume it is 64-bit. It is 64-bit operating system. Then what will be the address of next element? So for 64, what is the size of integer? 4 bytes. So the address of next element will be 104, 108, 112, 116. This is the meaning of continuous memory locations. Since array is of type integer, I am considering 64-bit, so it is going to occupy for each element 4 bytes. Even it's of type float also 4 bytes. Character means 1 byte each. So this is the meaning of continuous memory locations. And the main important point is, array elements are accessed using indexes, and the index starts from 0. 0, 1, 2, 3, 4, like this. Meaning we can write like this: n of 0 equal to 10. So what will happen? 10 will come and store into this n of 0 location. If you are writing n of 1 equal to 20. 20 will come and store into this n of 1 location. So similar way, we can write, just a second. Similar way we can write n of 2 equal to 30. The values are our wish. N of 3 equal to 40. N of 4 equal to 50. So what will happen? 30, 40, 50 will come and store over here. Got it? In this one, this 10, 20, 30, 40, 50, we call them as elements or values. Values are our wish. This 0, 1, 2, 3, 4, we call them as indexes. And this 100, 104, this I'm assuming it starts with 100. So these are our addresses. Right? So the important points are array elements are accessed using indexes and starts from 0. The index starts from 0. The next important point over here is the starting address of an array is called as base address. In this example, what is the starting address of this array? 100. So that we call it as base address. And the base address is stored in the array name. The base address is stored in the array name. Like example, if you are printing like this, printf %u n. If I just give array name, it's going to display 100 because, and %u means unsigned integer. So %d means signed integer. Signed integer means positives and even negatives. Positives and even negative. Unsigned integer means only positive. Because addresses will always be positive only. Address will also always be positive. So we have to go with positive means %u. So in our example, what value it is displaying? 100. So what is this 100? The starting address of your array. The starting address of your array is stored in your array name. So what is our array name? N. So whenever we display this n value, what value it's going to take? The starting address. This starting address only we call it as with a special name, base address. Right? So this is very, very important point. Clear this point up to here? Clear this point up to here, Tejasvi? Right. Now, let us understand this with the example programs. Write a program to create an integer array of size 5. I'm going with the size as 5. And display the elements of the array. Just creating a display. Array create dots. Open developer C++. Create a new source file. # include stdio.h main function. So I'm taking a array n of size 5. So n is what? Array. So whenever we use this square brackets, that indicates it's an array. Now take the variable index I. So what is the need of I variable? To manage the indexes. Now go with the message. Enter 5 values. Enter 5 values. Now how to access array elements using indexes? and the index starts from 0. So 0, 1, 2, 3, 4 like that. So go with the for loop. So 0, 1, 2, 3, 4, it's a sequence. So we go with for loop for I equal to 0 because index starts from 0. I less than 5, I plus plus. Now write here scanf %t, comma, and n of I. And n of I we have to use. Now let me elaborate this for loop. See how we are storing the value into array? For loop. So for I equal to 0 because index starts from 0. I less than 5. Why we are going with 5? Because the number of elements are here 5. Then I plus plus. Now write here scanf %t, comma, and n of I. And n of I. See, the initial value of I is what? 0. 0 less than 5, yes. Comes to scanf and n of 0. And n of 0 means this address. So address of n of 0 means 0 index. So the first value what we enter, it will go and store into this 0 index. Now the control comes to I plus plus. I will become now 1. 1 less than 5, yes. Again scanf and n of 1. So second value will come and store into n of 1 index. Like that, n of 2, n of 3, n of 4. After 4, I plus plus 5, 5 less than 5 false comes out. So when you say I equal to 0, I less than 5 means it will take indexes from 0 to 4 only. So when I value becomes 5, condition false comes out. So this is the piece of code we need to write to store the values into array. Now, once we store the values into array, I want to display the array elements back. I want to display the array elements back. So go with the message printf slash given array elements. So again same for loop only. To store the value into array also for loop only. To take the value from array also for loop only. I equal to 0, I less than 5, I plus plus, then print the values. Printf %t space n of I. That's it. So I is the index. So whenever you want to store the value into array also for loop only. To store the value into array for loop only. To get the value from array also for loop only. So because the array elements are managed using indexes. If you understand index concept, that completes major part of arrays to us. Now let me save this. Array create.c. Compile and run. So it is asking C 5 values. You can go with any 5 values, which is going to display the elements back to us. So this is storing value into array. This is returning the value from array. That's it. If I want to manage 100 elements, just replace this one with 100. That's it. No change in the code. Only this part. Only this part we have to change here. Okay. So clear? Tejashwi up to here.
Yes, sir.
Right. Now, let us go with some more examples. Write a program to find sum of given array elements. Sum of given array elements, meaning we want to add these values. That is 10 plus, 20 plus, 30 plus, 40 plus 50, which goes to 150. The result is what? 150. So what is the logic of sum program? We should take a variable sum equal to 0, and whatever the value we are accepting into n of I, take that n of I value, add it to sum, put the result back again into sum. That's it. So what is the logic of sum program? Whatever the value we are accepting into n of I, take it, add it to sum, put the result back again into sum. Now write this code. array sum dots. Create a new source file. Main function int n of 5, index I, initial value of sum, let us take it as 0. Now go with the message printf enter 5 values. We'll set for I equal to 0, I less than 5, I plus plus. Now write here scanf %t and n of 5. So once we accept the value into n of 5, what is the formula? Take that n of 5 value, add it to sum, put the result back again into sum here. That's it. Once the loop is completed, print the value of sum. Sum equal to %t, comma, sum. Now, let me go with the name array sum.c. Now, compile and run. Understand carefully, very important. I am going with 5 values 10, 20, 30, 40, 50. Then, what do you think the output of this program is? What is the value of sum it is going to display? From this program?
150.
150? No, not 150. Think.
What?
How many statements are there in for loop?
Oh, the bracket is missing.
Yeah. So how many statements are there in for loop now? Only
One.
statement. So only one statement. Now you think and say what is output now?
Hmm.
Still output what we get? It's
Zero
given something
only.
like 0.
Oh, okay.
Because this statement belongs to for loop? No,
No.
right? It won't belong to for loop. So this line will execute when the for loop is completed. When the for loop is completed, when this condition becomes false. When condition becomes false, when a value becomes 5. So 5 less than 5 false. Comes out, takes this n of 5 value. What is n of 5 here? No 5 here at all. It is not there here. So that's the reason. So it is replacing this as 0. So 0 plus 0 we are getting 0. In some of the other compilers, we may get some other answer also. We may get some random answer also. We may get for us. But in Java, if you take Java, it won't allow you to access it all. In Java, we cannot access array out of index at all. But in C language, it's going with what? Output 0 here. How to make this program correct? Using curly braces. After accepting the value into n of I, immediately take this n of I, add it to sum. So this sum equal to sum plus n of I should also be a part of for loop. Now compile and run. If I take 5 values, now we get the correct result 150. Clear this program? Any questions?
No, sir.
Let me discuss one more example. Write a program to search an element from the given array. Array search. So what is the meaning of search operation? Let me elaborate. If you take an array with 5 values, let us take 5 values in this array. All these elements are connected to array n and the indexes are 0, 1, 2, 3, 4. Now let me go with the array elements like 5, 8, 6, 4 and 7. Now in this array, do you have an element 6 here? Yes. So we are having element 6. So we have to go with the message found. In this array, do you have element 9? No. So we have to go with the message not. So that is the task here. So I have to just check whether the element is present in array or not. Now, so let me explain the logic here. The element whichever you want to search, that will store it into key variable. The element whichever you want to search will store it into key variable. And we take one variable called as isPoint as 0 initially. 0 means false, means the element is not present in the array. We initially consider the element is not present in the array. How to do that? By assigning to 0. 0 means false. Now take for loop for I equal to 0, I less than 5, I plus plus. Now we have to compare. If the value of k equal to n of I, if the k is present in array, see here, let me elaborate. Initially k is what? 6. Initial value of this bond is 0. Comes here. I equal to 0, s. I equal to 0, s. 0 less than 5, sorry here. I equal to 0, 0 less than 5, s. Comes to if condition. 6 equal to n of 0, no. Because n of 0 contains 5. So 6 equal to n of 0, no. Now the control goes to I plus plus. I will become now 1. 1 less than 5, s. Comes to if condition. 6 equal to n of 1, no. Again I plus plus 2. 2 less than 5, s. 6 equal to n of 2, now it is true. Now it is true. Then immediately we should make is found as 1. 1 indicates true. 1 indicates for true. Then once the element is present in array, do I need to compare with other values? Not required. So if you don't want to compare with other values, I can come out of loop using break. So what is the use of break keyword? To come out of loop. Then once we come out of loop, now you check here. If the value of is found has become 1, if the value of is found has become 1, then we'll go with the message found. Now, so in this example for 6, the value of is found will become 1. So we go with the message found. If I take the element as 9, I want to search for 9. Initially is found is 0. Comes here. I equal to 0. 0 less than 5 s. Comes to if condition. 9 equal to n of 0. No. Again I plus plus. 1 less than 5 s. 9 equal to n of 1. No. Again I plus plus 2. 2 less than 5 s. Comes here. 9 equal to n of 2. No. N of 3. No. N of 4. No. After 4 I plus plus 5. 5 less than 5 false. Comes out of loop. Once you come out of loop, what is the value of is found? It is remaining as it is 0. So 0 equal to 1 false, comes to else part, and we go with the message not found. That's it. So if the element is present in array, the value of is found will become 1, else it will remain as it is 0. Clear? Tejas, with the logic of this code?
Yes, sir.
Right? Let me write the code for this. So this is important during your exams. This program is asked more in our exams. Open developer C++, create a new source file, include stdio.h, main function, int n of 5, I variable, and initial key variable, and is found initially I'm taking it as 0, means false. Right? Now go with the message printf, enter 5 values. We'll set for I equal to 0, I less than 5, I plus plus. Scanf, %t, comma, and n of I. So this is array creation. The array is ready with values. Now ask for the element which you want to search. So go with the message printf /int, enter value to search. we'll store it into key variable. Scanf %t, comma, and key. Now we have to check whether this key is present in array or not. How to check? We have to take each and every element. For I equal to 0, I less than I less than 5, I plus plus. Now compare. If the value of key equal to n of 5, if the key value is present in array, immediately we'll make is found as 1. Means the element is present in array. Then we come out of loop using break. So if the element is present in array, the value of is found will become 1, else it's going to remain as it is 0. Now after loop you check here. If is found has become 1, then go with the message printf found. Printf found, else printf not. That's it. So we can even replace this one like this. Even you can remove this. Just you can even say if is found. If is found is 1, it replaces 1 here. If 1. 1 indicates true. True means found. If the element is not present, is found will be 0. If 0, 0 means false. So it comes to else part and says not found. Save this. Array search dot c. Now compile and run. Go with any 5 values, 5, 8, 6, 4, 7. Enter value to search 6, it will say found. If I run the code again, if you take the elements 5, 8, 6, 4, 7, I want to search for 9, it will say not found. If the element is present in array, it will display message found, else not found. Clear this program, very important.
Yes, sir.
Right? So please practice all these things. And tomorrow we'll go with the two-dimensional arrays. Tomorrow we'll complete two-dimensional arrays. So next 4 classes, attend the classes. All these 4 are very important. Okay? Right? So tomorrow we'll see two-dimensional arrays. How to create two-dimensional arrays. And we will even learn how to find sum of diagonal elements, how to go with sum of matrices. Those all programs we'll discuss in tomorrow's session. Okay? Right. Thank you.